Hello, my name is Dominic Ramos, and together with Professor Seung-Hoon Hong, I am your co-moderator for today's session on cross-border interoperability via digital twins in practice. We are talking with you in the upcoming hour about a Korean-German testbed on the asset administration shell technology and all its surroundings. I'm very excited to hand over now to my co-moderator, Professor Hong. Professor Hong, please.
Thank you, Dominic. My name is Seung-Ho. Before we start our live stream event, I have one thing to announce. After 25 minutes of this live stream, we will continue the Q&A session. Anyone who wants to join the Q&A session can push the link for Q&A call button below this video window. That will automatically bring you to the Q&A session. And during the live stream, the audience can send their question using the Q&A service window. Now, Dr. Dominic Ramos in RNI 4.0 will give an opening remark of this live stream event. Dominic, will you start your opening remark with a brief introduction of yourself?
Thank you very much, Professor Hong. It is a pleasure for me to also give the opening remarks for our session. I am the CTO of Labs Network Industry 4.0. You see the logo on the bottom right side. I would like to start, nevertheless, with the top side. You can view that as a top-down approach and bottom-up approach. So on the top, you see the German Platform Industry 4.0, and I'm introducing here the triangle of the German Platform Industry 4.0. The German Platform Industry 4.0 is working and taking care of two things. First of all, internationalization. That's why we are here together with our friends from Korea. Secondly, they have working groups and a library, and they are the initiators and the drivers for the digital twin. So the asset administration shell, which is the implementation of the digital twin, the topic of today. On the bottom, you see Labs Network Industry 4.0. It's a pre-competitive non-profit association which operationalizes all these Industry 4.0 aspects, technologies, and use cases in form of a test bed where we really test cross-vendor in a neutral way, on a neutral place, these Industry 4.0 technologies. And the results of these tests, of these use cases, are handed over in Germany to the Standardization Council Industry 4.0, which then operationalizes and synchronizes the international standardization on these topics. Thank God, Korea is a very close and core partner in our IEC working group, TC65 working group 23 and 24 activities. They support together with us the endeavor of the industrial digital twin and the asset administration shell technologies. With this overview, I show you briefly that we finalized that in the form of a memorandum of understanding, which was signed in December last year electronically. And we were very proud and humbled that also the ministers of both countries, the economy ministers, took place in that signing ceremony. Thank you very much for attending today, and I hand over back to Professor Hong.
Thank you, Dominic. Next, Dr. Birgit Boss in Bosch Connected Industry will present why do you need the AAS and how help IDTA with her brief introduction.
Yeah, thank you very much. My name is Birgit Boss. I'm with Bosch. And I'm the chair of the working group on asset administration shell and also member of the board of the newly founded Industrial Digital Twin Association. So I would like to start with a very simplified statement about digital twins. What are digital twins about? Digital twins are about making abstract data comprehensible. And why do you need it? Have a look at a typical factory or production line today. You have a lot of machines in your factory. You have a lot of robots from different suppliers, automation systems, vehicles, whatever. And all these different machines produce data, and they produce it in a very heterogeneous way. And so the integration costs are quite high because these applications on the top here, they want to consume the data, but the data harmonized. So what we need is now a standardization of the data. And this is how we are doing it in the Platform Industry 4.0 in our approach of the asset administration shell. We use a property value pair. So here you have a value 2000, and now the question is, what is it? Is it the year 2000? Is it 2000 euros? Is it 2000 steps? And it's not clear when you only have the raw data. So what you need is a semantic descriptions. This is the semantic descriptions of this value. In this case, we call it semantic ID. This is a semantic ID of the E-class dictionary, but you can also use other dictionaries. And when you look up this ID in the dictionary, you will get the following information. You will learn that it is the maximum rotation speed. You will learn that it is measured in rotations per minute. And you will also get a definition. Here it's the English definition, but you might also get the Korean definition or the German definition, whatever language you need. So this is how we put semantics to data. And I think Dominic already said it. So the asset administration shell is the implementation of the digital twin in Industry 4.0. And if you want to implement digital twin, you may ask yourself, which standard to use and where to get support to also implement it. And so I'm very happy that last year it was driven by Platform Industry 4.0 to give a kind of home to the asset administration shell and to give such support that is requested by the users of the asset administration shell. So the goal is to have exactly a one-stop shop for the digital twin, and this is why the Digital Twin Association was founded. There were more than 20 founding companies in this association, and so we are very happy that in March this year the website went live. And now you see here, these are the founding members, but now it's also possible to join, that other members are joining the Industrial Digital Twin Association. So we would be happy if you would join, and you see you would be in very good company. Here are the goals of this association. So the first, I think the most important thing is to really set up a global and international community and to really drive further the international standard of the industrial digital twin of the asset administration shell. We want to use open source technology and open source approaches, and especially with respect to the submodels. I think Dr. Hofmeister will talk about it later. We want to provide a comprehensive catalog with information models so that you can be sure that this will lead to interoperability in the end. And that's what we are talking about. Value will be created through the fusion of OT and IT. And like we always tell when talking about the asset administration shell and Industry 4.0, it's always covering the complete life cycle and the complete value chain. Of course, in the end, we all want to do business, so it is about digital business models and what I want to stress, it's not only for big companies like Bosch, it's really something for companies regardless of their size. So it really, everybody can and should think of implementing digital twins in a standardized way. And our thinking is that in the future it will be a prerequisite to have such a digital twin approach with every new architecture set up and every new business model that is based on data. Yeah, so again, I would like to ask you to join the Industrial Digital Twin Association, and yeah, let's shape the future of industry together. Thank you.
Thank you, Birgit. Next, Professor Juyeon Lee in Seoul National University of Science and Technology will give the AAS pilot plant project in Korea. Dr. Lee, will you start your presentation with a brief introduction of yourself?
Thank you. Hello, everyone. This is Juyeon Lee. I am a professor at Seoul National University of Science and Technology. Today, I will introduce the AAS pilot plant project in Korea. This pilot project aims to develop the AAS standard-based data collection system, and we apply this system to the real shop floor for verifying the performance. So as you can see here, the system consists of the Edge gateway and cloud platform, which are communicated via OPC UA, and all data flows among system modules are based on AAS. So for the AES modeling, we mainly focus on identification data and operation data. So as you already know, identification data deals with the identification information of AAS and asset, and operation data includes information related to the actual operation of the asset. Let me explain how to implement AAS from the AES modeling point of view. I've defined 6 steps for the AES modeling. So first is the planning to determine the scope of AAS, and then it's important to investigate target asset in their data collection infrastructure, including hardware and software. And based on that, we can generate the model of an asset itself, including structure and static data model and so on. And after that, we can also generate the AES model and implement those models using the AASX package explorer. And lastly, the system can be implemented based on AAS, and the AES model should be verified and validated. Actually, I can't explain each step in more detail here, but I want to emphasize that investigating an asset itself before modeling AAS is very important. So for this project, we have 2 pilot plants. So the first plant is Sinuk Costec, which has the PET 3D IML injection stress flow machine. So this machine consists of 4 main processes from injection, reheating, and stretch flow molding and labeling, lastly takeout. So we generated this AES model red box, considering the machine processes. So there are the AES models of PET 3D IML and injection machine module and blow machine module, label machine module, and product and injection mold and blow mold and label. And this AAS-based data collection system was implemented to the real shop floor of Sinuk Costec. So they are now using our system for real-time data monitoring. And our second plan is Huon's. So we applied our system to the ampoule manufacturing process of this pharmaceutical company. So we generated these AES models of main equipment in this ampoule manufacturing process, such as pharmaceutical preparation equipment AES or ampoule washing equipment AES and so on. So in this presentation, I introduced our project and our two pilot plans very briefly. So if you have any question, you can join our Q&A time. Thank you.
Thank you, Julian. Now I will hand over my role of moderator to Dominic. Dominic, can you take over me?
Yes, thank you very much also from my side, Dr. Lee, Professor Lee, and I will hand over now to Dr. Won Seok Song from Nestfield. He will present AAS-based plug and produce testbed. Dr. Song.
Hello, everyone. My name is Won Seok Song, and I am managing R&D in Nestfield. As you see, we have been researching industrial automation technologies. Hanyang University verifies the core technology, and Nestfield commercializes it. We recently published a remarkable research achievement related to Industry 4.0. We have focused on smart manufacturing core technologies such as AAS, OPC-UA, TSN, and we are verifying the feasibility using plug and produce scenario. Our test bed consists of 3 layers. As you see from the bottom, the field layer is network-based control system. It consists of 3 robot arms and 1 turntable and controllers. The platform layer in PMP and the communication layer in TSN integrate the field layer using edge gateway. The cloud layer controls and monitors the whole testbed operation by user interface dashboard. The plug and produce is one of the adaptable factory scenario defined in IEC TC65 Working Group 23. The adaptable factory scenario explains a flexible production line that can be reconfigured during runtime. Like plug-and-play concept for desktop computers, the vision is to have plug-and-produce capability for future production line. In operation mode, a pair of robot arms are working pick and place. In PMP mode, one of the operating robot arm to be plugged out and one robot arm to be plugged in to replace it. And then new robot arms are executing the pick and place task on the turntable. During this process, AES robot arms and turntable will communicate to determine the operation of corresponding assets. Our testbed can also verify the benefits of TSN real-time characteristics. TSN can support deterministic and real-time communication for time-scheduled traffic. This can guarantee the bounded latency for scheduled traffic. Our TSN testbed includes 2 TSN switches. Some TSN talkers generate scheduled traffic, and video server generate a video stream as unscheduled traffic. Hanyang University developed a unique TSN scheduling algorithm. In normal condition, traffic latency does not affect the control system. But in high load condition, network traffic is saturated and unscheduled video streams are frozen by latency, while the robot control is still normally performed due to TSN scheduled traffic control. This demonstration shows that TSN can guarantee the bounded network latency for scheduled traffic. You can see the demonstration video about PMP and TSN testbed on the following link. Thank you.
Thank you very much. I immediately hand over to Dr. Hoffmeister, who will present the AES content delivery from SAM models to standardization. And please be aware to be a little bit faster because we are already late. Thank you, Michael.
Yeah, thank you, Dominic. I want to talk about content delivery, because if we talk about interoperability, we really need to care about how information is conveyed from a machine, for instance, to another machine. And this means that we also have to discuss which kind of information elements should be there, and these information elements should be standardized. And this is what we typically for the asset administration shall call submodel definitions. But first of all, let us have a look how the standardization approach for the asset administration shell looks like. If we look to the topic of digital twin and digital thread, we see that almost all important standardization organizations are active, such as ISO, IEC, JTC1 or IEEE, with a lot of different working groups and supervisor committees. And in order to focus the discussion about the asset administration shell, we founded a working group 24 in the IEC Technical Committee 65. And here we have the place to dedicate our discussions to the asset administration shell, the structure, the information meta model, but also which kind of security provision should be in there, and to do also a specification of content. So because content is important to be exchanged and to be standardized. And here from this testbed activity, Dr. Birgit Boss, Professor Hong, and me, we are all active also in this working group, and therefore this is really a good means also to convey the discussions into the international standardization. But however, we will have a lot of other user activities, and here Birgit Boss already introduced IDTA, the Industrial Digital Twin Association, and our idea is to take the technology and also to take up the content definitions in form of submodel propositions from the IDTA, and then have a look again also on the IEC and ISO, which of these submodels could even be standardized in an international way. But now let us talk about these submodel specifications. We already have some of them available, and Professor Lee was already so kind to introduce them also to you. We have for the identification the digital nameplate submodel description, for describing technical data such as data sheets in multiple languages and so on. We have the technical data specification, and we have also for the important topic of documentation and certificates a way to interoperably convey them along the supply chain by using the handover documentation submodel. However, we are doing a lot of more. You have just introduced by Dr. Song to the operational modules you have seen in the Nestfield demonstrator. We are working on submodels for simulation, for virtual commissioning, and a lot more. Many of them will be then published in the online library of the platform industry for all, in the IDTA organization, and also via the IEC. How can you now join this commitment and this development? We are providing open source technologies for you. We have a central information place here on GitHub where you can go and find a lot of different software development kits. You find there are more than 30 examples for asset administration shells, screencasts, binary versions of our editor, for instance, but we have also a server, Docker container, security provisions, and much more. And last but not least, I want just to give you an impression how this editor works. Here, I'm now starting the activities, and I'm starting now to download a asset administration shell directly from the machine. Here, this small production model. I'm going into the documentation. The documentation is available in multiple languages, and the documentation is already included also into the asset administration shell. You don't need to search them in the internet. Everything is at one place. And
Michael, thank you very much. Our time is out and we will be cut off from the broadcasting. To all participants, please push now the conference room link below, and it will be our pleasure to hand over to Professor Hong for now the Q&A session. So to all participants in the live stream, there's a conference room link below. Please push that button. And we continue now for the upcoming 35 minutes in a Q&A session.
Okay.
Professor Hong, please give your closing remarks for the live stream of today.
Okay, I will just briefly introduce what I plan to give a presentation. Actually, my name is Seung Ho, professor of Hanyang University, and I am chairman of the Committee of Smart Manufacturing Standard Technology. Today, I'd like to give a presentation about the cooperation of AAS Testbed between Korea and Germany. Professor Yuan Lee already gave a presentation about the first stage of AAS pilot project. In the first stage of pilot project, we developed the data acquisition and storage system using AAS technology, and we need to continue the AAS pilot project, planned project to the second and third stage to expand the AAS technology to the whole life cycle of the production process, including operation, management, prediction, and decision making. And we are planning to build a reference AAS model repository so that they can be widely utilized by various vendors and service enterprises. Also, we will develop and promote AAS API standard so that the smart manufacturing related service developed from startup to large enterprise can be easily implemented and deployed. In order to achieve these goals, cooperation of AAS testbed between Korea and Germany is very, very urgent. And from the cooperation, we can provide internationally accredited AAS reference model for essential asset in the SME and promote standardized smart manufacturing solution to Korean society. Also, it can be help improvement of the international competitiveness of Korean vendor, and by adopting digital twin technology of AAS based I 4.0 component. Okay, that is what I have.
Thank you very much, Professor Hong. Mm-hmm. It's my pleasure. So we now move on to the already started Q&A session in the conference room link that you just clicked before. And I am very happy to read that the first questions are coming in. We will do the following mode, that we read the questions to you and then give answers accordingly. So I would like to start with a question directly to you, Professor Hong.
Yeah.
How will you just mentioned that the question is, you just mentioned the German-Korean testbed on this interoperability technology asset administration share. Mm-hmm. So how will both countries, so I assume South Korea and Germany, expand the scope of their cooperation in the future?
Okay, yeah. Currently, actually, we are cooperating in the testbed development itself. But in the future, we expected that the cooperation will be expanded to first, maybe we can share the reference AAS repository developed by Korea and Germany. And maybe in the second, we can develop a common AAS API standard together. And I think we both Germany and Korea, we can do many more things to be achieved that we can achieve in the future for the cooperation of AAS technology.
Thank you very much. There's another question coming in for you. Mm-hmm. It's the same tone that you just answered already, but let me read it to you. Okay. It's about the benefits.
Yeah.
So what are the benefits of having this cooperation on AAS also on the Korean side? So it's a Korean question.
Okay, yeah. Actually, at the beginning of this AAS pilot project in Korea, Actually, in Korea, we implemented the AAS technology using the specification and published article from Platform Industry 4.0. But at the time, we were not sure whether we are going to the right direction. But after we make a cooperation with Germany, we discuss a lot of items with the German expert. And after that, we were able to get confidence about what we are doing to develop the AAS in Korean side. So it was a very, very, very nice and very helpful cooperation between Korea and China to develop AAS Testbed, and we are expecting more cooperation in the future.
Wonderful. Thank you very much. Questions are coming in like crazy. I would say that you hand over briefly. I just recognized that there's a quite general question coming in for the international cooperation. Let me answer that, Professor Hong, and continue the line that you just mentioned before. So the question coming in is, why is Korea and Germany collaborating on Industry 4.0 in general? Yeah. And that was already partially answered by Professor Hong just before. Interoperability, Industry 4.0, networking in industry, the IT and OT convergence is not a national topic. It is per se an international topic. In particular, if you think of the pandemic times, you recognize that global value networks are global and not regional or national. And this is our mindset and our setup. This is the logic why it is completely clear that Germany and Korea, but also Germany and other countries, as well as Korea and other countries, are collaborating on smart industry and Industry 4.0. For us, it is very important that we do that with the supporting of standards and normative activities. It doesn't make sense that cross-vendor situations occur where not standards are used to solve the challenges which are stated in Industry 4.0. We need synchronized global normative activities to have Industry 4.0 realized on a global scale. I'm very happy that several speakers before me elaborated already on this need and on the standards for the asset administration shell as one and the key technology for Industry 4.0 implementation. So I think the second question which just came in, why is the AAS technology so important for international collaboration, is also in that round. And let me really say that the asset administration shell, as the implementation of the digital twin, is the technology that will interoperate all different assets. It was already mentioned in the presentations before, but let me elaborate on that briefly. Each asset, so let's say a thing with a value for you, for your operation, for your company, for your department, for your engineers, etc., will be able to be interconnected. Interconnected is not right, to interoperate with each other. And this to be done in a standardized way will cut barriers and obstacles at interfaces, at different domains that in these days we have to bridge with manual processes with a lot of human interaction. And if we have semantic interoperability, which is the asset administration shell for all things, for all assets, then those barriers, and by that the cost, will lower dramatically. That would be it from my side. Professor Hong, do you want to take over with some questions coming in like crazy?
Yeah, okay. I have a very interesting question at this moment. One question to Dr. Bill Gates. Is it only E-class that is supported for semantic description by the AAS?
No. So the asset administration shell is very flexible. As I said, the only request we do have that it's a globally unique identifier, so that it's clear where to look it up, so where the semantic is defined. Of course, the Platform Industry 4.0 is recommending to use E-class, but you can use also any other standard that is, or also your proprietary definitions. You can even use proprietary concept descriptions if you have an identifier. So the main thing is to have a global identifier, so where you can look up the semantics. So it's not only E-class, you can also use IEC CDD and a lot of other dictionaries.
Okay. Maybe similar question can be given to Juan Lee, Professor Juan Lee. Here, what are the benefits of this pilot project to the applied target company?
Actually, from this pilot testbed, we can figure out what is requirement from the company, weird company, because I think standard is very abstract and general, but if we apply that standard to the weird field, weird shop floor, we can figure out which is difficult part, which part is important, what they want from this AES standard. So I think that's the benefit of our testbed. And then we can implement the reference model for AES from this testbed project, I think. Yeah.
Another question for you. During this pilot project, what was the most difficult part?
I think collecting data part is the most difficult part, because when I did this project, there was no well-defined document for understanding the stat. So I should search all information by myself. So I think that's the most difficult part. I think, but that's also general, usual situation, because usually manufacturing company don't have any well-defined document for which can explain this set have this kind of structure, or this set contain this kind of data. They don't have that. So I think that's very usual issue. So.
Yeah.
Thank you. Thank you very much, Dr. Lee. There's a similar question coming in for Dr. Song from Nestfield. May I ask you, in continuation what just Dr. Lee said, it seems that the PNP testbed that you have has been prepared from the beginning for this asset administration shell. So this interoperability standardized on a global scale. How did you make the SaaS in Nestfield in your situation?
Yes.
Dr. Song?
Yes, we have been paying attention to the potential of AAS from an early age and the AAS technology. So we have implemented AAS in our testbed using automation ML first. Recently, we changed our AAS making tool from automation ML to package explorer. There's as we introduced in previous session, it is an open source software dedicated to make AAS and released in Germany. Now we are creating in accordance with the newly announced AAS standards and applying sub-models that were released in LNI 4.0. Yeah. Thank you.
Thank you very much. There's also another question. I think that's also close to you. What is the most difficult point when you applied AAS in your factory at your small medium enterprise in Korea?
Yes, for me, it's similar to Professor Lee. The most difficult thing in implementing AAS is that a lot of operational data used in the field is not yet defined in E-class or CDD. and I feel that the reference models for various manufacturing equipment would be needed. Fortunately, various sub-model templates, such as nameplate or technical data is introduced previous, are currently being introduced, and so I think it'll become easier to use AAS in manufacturing field. Thank you.
Thank you very much.
I have one interesting question from Korean side. Maybe I don't know who can answer to this question. The question is digital twin technology applicable to forging process? Maybe the questioner is involved in forging process. Who can give an answer to this question? Maybe Michael, can you answer to this question?
Yeah, this is quite funny, because we just had also in Germany a request, to provide a description of the forging process, especially if you squeeze the metal, you want to take a lot of measurement data, and you need to describe how this measurement data is being analyzed and transferred. This client wanted really to describe this kind of chain of measurement and that different analytics tools could be applied. Basically, I think we have to go then to the most important factory and production processes and look what has to be done here, and to describe them by submodels in a kind of process model with important boundary condition, with important measurement data, with important KPIs and recipe data.
Dominic, can you continue?
Yeah. Thank you very much, Michael. I would like to adapt a little bit to what you just said, and also to this question, and also to the comment of Dr. Song. Birgit, one question I think is addressed to you. Is it only E-class that support the semantic descriptions by the AAS? You mentioned that already in your presentation, but again, this question coming up in the chat. Can you say something on that?
I think I just answered it before. Probably, but it's a question I'm asked all the time, because all our examples typically are from E-class. But as I said before, no, it's not only E-class. We also even have examples where you could add ontologies. So we also think about more intelligent digital twins. So the good thing with the asset administration shell, and I think that's why it's successful, is that it is really flexible. It is not bind to E-class, but E-class, of course, offers a lot of already standardized properties. But as Mr. Song said, you don't find everything you need, not yet. So you have to have a possibility to also define semantics. Not everything you need is already there. And this is what the asset administration shell offers to you. So you can start right away without waiting until something is standardized in E-class. So E-class is good, but you also need something besides.
Okay,
thank you very much.
Similar question I also received from many Korean factory members, and they asked me, do we have to use only E-class or CDD to implement AAS? Though that's not true. So you just gave a very nice answer to that question. Okay.
Let me continue there. Also, another question to you, Birgit. Is it only possible for German companies to join this IDTA that you mentioned in your presentation, that, as you said, home of the asset administration shell? Or is it also possible for Korean companies?
Yeah, sure. So no, so it's not a German association. It's really the goal is to build up an international community. And as I tried to say, it's now possible for everybody, so for every company to join, also for non-German companies. And we already have our first non-German companies as members of the EDTA, still from Europe. But the goal is to really have international community on digital twins, because as this testbed also shows, it is not about Germany, it is not about Korean, it's about cost crunch, interoperability. Yeah, it's about interoperability. So that's why it's very important. Yeah, please join and have a look at the website for more information.
Great, thank you very much. Michael, there's a question for you. I'm missing a certain aspect in the asset administration shell. How can I start the standardization of a submodel? That was already addressed by Dr. Song. You remember when he said, I had to do a lot by myself? Yes. What is your perspective there?
Yeah, I think one of the biggest strengths is that we are not dividing into standardized information and proprietary information sets. Yeah, so it's a very good start, as Dr. Song was expressing, is to start in the own company and to create a submodel for a certain aspect, which is important for your production. And as soon as you then have the feeling that this kind of information set, submodel specification, is also important to other users, then you can, for instance, approach the IDTA and say, okay, I think this is something which is representative for a certain domain or for a certain branch. Let's go here and try to do a standardization. And then together with the IDTA, you're looking for representative companies here, that you get a kind of minimum share of the market, and then we can define this submodel and declare this also be standardized and to be applied if a certain kind of aspect or domain is to be described via the asset administration shell. And by this mechanism, we are guaranteeing that certain domain, only one submodel specification is being recommended and not a lot of them.
Let me add just a question which just came in seconds ago about MES and ERP systems. How do you integrate all what we learned, AAS technology, with MES and ERP systems, possibly also with existing MES and ERP systems? Michael, do you want to take that over?
Yeah, we have a running activity here, especially for the MES or MOM, Manufacturing Operations Management, that all the interface descriptions, which are, for instance, described in the IEC 62264 standard, could be expressed also via asset administration shell. And same goes true with the semantic descriptions of recipe data. And by combining these two submodel aspects, you would be able to, for instance, move in a lot into a machine and then say, okay, please process this with a certain recipe. Please record the data. We have a submodel description for time series data and data analytics, what I just mentioned here before. And therefore, we are also able with coupled AAS in the factory level really to enrich the world of the MOM and the MES systems.
Super. Professor Hong, questions are coming in like crazy. Do you want to take over? You have to unmute yourself, Professor Hong. Unmute yourself.
I have one interesting question from Lakshay. Just to repeat and be on safeguard, that question is not lost. How do you explain the difference between implementation of AAS on I4.0 network, which would be based on service-based network, with the difference of I3.0 existing network, which help in releasing the need of real-time communication? Is AAS replacing that I3.0 network, or will supplement the existing network while creating new way of storing and accessing data? I think Mr. Mondeja think AAS to be a kind of network technology, but maybe Mike, can you answer to the question?
Yeah, and I think this is really a very important question, because we already have a lot of established technologies inside the factories, especially when it's about real time, and we will not substitute this. You can think of that we get an additional layer on top of this real-time layer, where we are able then to orchestrate and to arbitrate these kind of real-time activities. So on this top level, machines and components are describing themselves by the means of the AAS. And then, for instance, for a collaboration, handing over the real-time collaboration to the respective networks, might it be TSN, might it be Profinet, or might it be EtherCAT or something different. Yeah, so we really want to maintain what is being installed in the factories in terms of these important networks. We want just to provide a layer for more descriptive information on top, and to be able to orchestrate the activities here via asset administration shell.
Professor Hong, let me take over. I have a question which comes in, I think, for both, for Dr. Lee, but also again to Nestfield, to Dr. Song, about OPC UA. So there's one question. I think you should address that, Dr. Lee. Is it mandatory to install OPC UA to collect data for the asset administration shell? So all this submodel discussion around OPC UA companion specifications and all that topic. Can you answer that, please, Dr. Lee?
I think Dr. Song also can answer this, but I will do my best to answer this question. Sure. I think it's not mandatory to use OPC UA, because already the manufacturing company have already other communication way for their real factory. For example, they use Modbus or other DIO way for their MES or other information system. For example, in our Huon second pilot plant, Huon case, they have their own MES system, and they want to use their MES or their infrastructure for our projects. So we developed some converter interface between MES between MES and our system. So we developed some kind of converter from their infrastructure to our OPC UA module. So I think there can be many way to apply AES to the real shop floor, because when they want to implement AES, it's not easy to install all OPC UA or new infrastructure for that. So I think we need a very practical or useful way to apply AES. So that's
wonderful.
My opinion. Or
thank you very much. Yeah, Dr. Song, possibly you can also add to that. So the connection of AAS and OPC UA.
Yeah, okay. Yeah. I think the OPC UA is not mandatory, but most adequate because it has and support information model, and it fit to AAS to communicate using AAS. The second issue, connect AAS with OPC UA. It is a kind of big challenge for me because there's no standard way or guide to make it. So we made first AES model of facilities and process using Package Explorer, and then export OPC UA information model from AES. To make it possible, we make some parser program, and our parser generate a field data mapping table in this file automatically, and we can connect the actual OPC UA tag data to AES properties by use of this mapping file. So in order to make it easy to use many companies, so we have focused on auto configuration using AAS. I guess it is a very important thing, the auto configuration by only AAS. It's our concept. Thank you.
Thank you. You know what? There's just a question which is close. Birgit, is there because it's about realization, is there a standardized API for the AAS? Michael showed already the GitHub. Birgit, do we have an API for the AAS?
Yeah, it was just released in last year. As for the information model, we start with a technology neutral way of standardizing the API, but very soon we will have our first release on the HTTP REST interface and API, and I think this is a very, very important step to really also have runtime data available in an interoperable way very soon. Yes, we will.
Great. Thank you very much. Professor Hong, a few more questions are there. I see still coming in. We have only 3 minutes left.
I have one interesting question to Michael. Will AAS contain only standardized information?
No. I think this is really crucial if you want to automate and to do plug and play in the factory. We are allowing both proprietary information in the AS and standardized information. And it is really important that we allow this proprietary information as well, because then every vendor, every supplier, but also software companies can bring in their own information model into a standardized infrastructure and do not have the need to create a shadow infrastructure for their proprietary networks and information. And these shadow infrastructures, they are hindering us to realize something like plug and play, because typically we cannot administer these kind of shadow infrastructures. And therefore we want to bring all this proprietary information also into the infrastructure of Industry 4.0, that we can provide such use cases like quick reconfiguration, plug and play, automatic update and maintenance of modules and things like this. This is only possible if everybody is using the standardized infrastructure, but also is able to use proprietary or consortium-specific information sets.
Okay. A similar question. Where is the data of AAS stored? What are the deployment options?
Yeah, this is also really a strength. We are agnostic, so you can store your asset administration shell on your device, or you can store the asset administration shell in a central IT server. We call this repository, for instance. And we are also able to store it on the cloud or in some cross-company networks. What is really important is also that we can spread submodels between different of these repositories. So you can have, for a certain asset, for instance, a drill tool, have some submodels on the tool itself, providing, for instance, motor current, but other things like engineering data or documentation can reside on a central IT server, even if the device is being switched off.
Okay. Thank you very much for your participation, very active participation. And I want to ask Dominic to give the final remark on this event, please.
Thank you very much, Seung-ho, for organizing and supporting this wonderful and already since years existing Korean-German collaboration. It is a big honor and pleasure that we can test and push forward the interoperability technology, which was discussed in this last hour, the asset administration shell, the implementation of the digital twin for Industry 4.0. I would like to thank all participants on that panel here for their active contributions, for their precise answers. We are available at the booth of Nestfield, and also at the booth of the German Platform Industry 4.0 and LNI. Continuing here at Hannover Fair, we wish you a very good success of the fair and the upcoming days for that. And again, thank you very much to all participants for this very engaged and great session here and all the good answers. Thank you very much from our
Okay,
side.
thank you.
Thank you.
Thank you.
Thank you, all of
Thank
you.
you.
Yeah. Okay.
Bye-bye.
Bye-bye.
Thank you. Goodbye. Thank you.